Hello, everyone. My name is Richard Henderson. I lead the technical teams in EMEA for TIgerGraph. And what we're going to be talking about today is a data technology, not surprisingly, particularly a database technology. But I really want to focus on the value that the technology is bringing. We'd be delighted to talk more with you about the detail around that. And indeed, we can do so at our stand later or in the chat or anything like that. But first, I want to just make sure that I get the motivation for this right. And so you understand exactly where TIgerGraph is used and why it's actually worth having. So inevitably, I'm afraid, there's a few slides. I'll try and keep it short. I want to leave as much time as possible to the end. So my target here is to have 10 minutes of slides, and I'll try and make sure that I don't overrun too much. Then I'm going to show you our next generation operational demo, which really takes what we learn from working with Jaguar Land Rover and a number of other clients around supply chain and really tries to bring it into making it into a tool that's useful for operational staff. So this is the key point. Reports are very good, dashboards are great for executives, but when you can start providing analytics, AI, ML, however they're driven in real time, then at that point there's a whole new world of operational activities that can be assisted. And I think it actually it's really important because it allows these data products to really improve the lives and improve the efficiency and productivity of your staff, your operational staff. Certainly that's the experience of our customers, and I just want to describe that a little bit here. So moving on to the slides. So supply chain optimization with TIgerGraph. So this is where this particularly works. We don't just do this in supply chain. Our tool is a general purpose data tool. We also work with customer support and marketing type activities. So what's traditionally be called customer 360. But where that's useful when you get real-time views is particularly in the customer support area. And one of our clients is the largest healthcare provider in the US. And they use our tools for exactly this. And they're seeing tremendous improvements in the efficiency of their customer support, which necessarily in healthcare tends to be a very high investment process. And that is also improving the opinion of their customers as well. So that it's kind of a double win situation because the customer support people are have the information they need in order to support customers. And they're also seeing exactly what the customers has done in the past few seconds. So therefore, it just makes it feel like an engaging process. We also do this in kind of activity in other areas as well. There's supply chain, and the other one is in transaction fraud, KYC, AML, and financial spaces. So if those are things that you are interested in apart from manufacturing supply chain, then hopefully you'll get an indication of how this could be useful, but we do have very specific things that we can talk about. Again, if you just get in touch with us, then we can talk about your specific use cases. So, given those caveats, let's talk about supply chain optimization. All of this is based on some work that we did with JLR in the first instance. We've actually got a number of customers around this, but we like JLR, Jaguar Land Rover, because it's big, it's a difficult problem, and the results were very good. And we're very fortunate that Jaguar are pleased enough with this that they provide references for us, and they talk to this in other sessions. If you ask, we'll give you links to that, which will allow you to actually see what they said directly rather than mediated through us. So the first thing here is, what does it cost? It says here, supply chain inefficiency cost UK firms £1.85 billion in 2019. I think that's a massively understated figure. I suspect it's more like 10 times that figure. That's just what people think it costs them. Certainly, when we were talking to JLR, what started as they thought as a £10 million problem, they actually worked out was probably a £400 million problem. And the reason that it was that big a problem was really because of the knock-on effect. It's not just the cost of dealing with the supply chain, it's also what that does to forecasting, it's what that does to quality, it's generally how the organization has to be spending money in order to continuously adapt to a changing situation. So this talks about supply chains are obviously, it's a large chain. You've got loads of upstream supplies as part of a supply chain, which is your suppliers providing you with what you need as inputs. In manufacturing, you take inputs and you manufacture outputs. And indeed, the suppliers' suppliers and the suppliers' suppliers' suppliers. So there is a huge chain of activity. And then downstream, you've got logistics, you've got wholesale sales, you've got multiple channels involved. So inevitably, particularly nowadays, it's a very, very complicated situation, which is exactly what our tool is designed to help with. More recently, obviously, we've seen things get even worse. COVID-19 has disrupted everything for everybody. It's made risk a very central point and measuring risk, particularly looking at risk in a more global sense. And of course, there have been other things locally. We've got Brexit to deal with, which has very clearly in the news created problems for people. The point being here is that this has driven a desire to be able to react better and faster. Now, up to a point, that meant, first of all, getting the data and just being able to see reports to understand where you are. But what I'm suggesting is that if you can bring that directly to the people, the operational staff, so they can actually work with the data directly, then at that point, you start getting tremendous synergies and tremendous productivity boosts for the people on the ground. This is our friend at Jaguar Land Rover, Harry Powell. He has given presentations around this, so I just want to quote him first. And his point was that he wanted, very ambitiously, to accelerate planning from weeks to minutes. And the key here is that you don't know there's a problem with your supply chain until something just doesn't arrive, or when it arrives, it's broken. You don't have an awful lot of time to react at that point. And the best plans in the world will fall over if a lorry has a breakdown, there is blockage at ports, there is a blockage on the roads. You don't have time to think about these things too much. There's an infinite number of ways in which they cause a problem, and you can plan for problems, but what do you do on the ground when it actually happens? Originally, and he quotes it here, in order to deal with a problem, it used to take weeks, and that led to some unpleasant responses whereby they would end up having to stock large amounts of inventory of parts to try and avoid, so that they didn't stop the manufacturing lines because they had a problem with parts. What we did was give them a capability to run the same reports and make it clear between 30 to 45 minutes. Now that 45 minutes, apparently 25 minutes of that was composing the PowerPoint to actually present the results of the report and to discuss it. So actually, the report itself ran in at less than 20 minutes. And what does this report do? This report effectively says, if something is a problem in your supply chain, how can I respond to it? And that's generically, that could be any part in the supply chain. A car has anything from 2,000 to 20,000 parts. So therefore, any one of those parts, there could be a problem. That problem can occur anywhere in the process. It could be in manufacturing, it could be in supply, wherever. The key point is, what do you do when that happens? And in manufacturing, particularly in large-scale manufacturing, it's a particular problem for them because it costs millions of pounds an hour to run a factory with all the people and the processes and the robots. As you can imagine, it's a huge deal. So the idea is you need to be able to do things quickly. So time to value. What we did, they asked us to come in and they didn't know who we were. We had made an awful lot of promises that we could help them. But the first thing we did was to work out how we can immediately look at this problem, this challenge that Harry gave to us. What we did was we did actually a 3-week proof of concept that turned into a 6-week proof of concept as we expanded the scope, because frankly, after 3 weeks, they didn't believe the results we were getting. So we had to prove that the results were actually correct. We took as much of their data as we could across 26 data sources. We created a proof of concept with them using their teams, their data science teams, and our staff who come in. This was done pre-sale. And in 6 weeks, we had proved the value of this. This was when we showed that actually the value of what we were doing went from 10 million to 100 million, which obviously made it worth doing. And immediately they moved to the point where they wanted to turn this into a production install. So we went from 0 to production, including all the infrastructure. We used cloud for this. They're on GCP as it happens, but we actually are on every cloud provider in 3 months. And within those 3 months, the first 3 months, they got a 250% ROI. So that is the kind of thing you can look for, and that's from the initial use case. We've got another 3 use cases in chain right now, so obviously this is something that they want. What does that look like? What does that even mean? I'll just go through a little bit of detail just to give an idea of what it is that we're doing that gave that sort of ROI. And this is actually, we stole this from one of their slides, but it illustrates it very clearly. First of all, you can see on the left the chain of activity. It goes all the way from orders. Those orders, you order a car which has features, so you decide what sort of features you want. Those features actually translate into engineering features. So if you ask for a sunroof, then an engineering feature would be the sunroof plus all of the other changes to the car that are relevant to the having a sunroof fitted. So you need a hole in your roof for starters to put the sunroof in, for example. That turns into parts. Those parts are then supplied, and those individual suppliers have suppliers and so forth. So you've got this quite long chain of activity. Actually, this is about 26, I think I said, about 26 separate data sources coming from different systems, a lot of them siloed. We haven't included here, forecasting was part of that, procurement was part of that. We are now adding warranty and tracking of parts through as well to this data model. So it's quite a large data model. So a couple of terabytes of data anyway, which we are analyzing in real time. And the particular risks they're looking at are, first of all, is the answering historic blind spots. So which parts are most at risk of shortage? So that's really interesting. So this is more of a strategic reporting side. So what is which parts, which if there is a shortage, there's going to be a problem, or where they've gotten something in the order book which they cannot fulfill with parts from suppliers. The other is, what are other sourcing options? That's not about predicted shortage or just about predicted shortage. It's also about how can you ensure that you're not exposed to problems. If a supplier has a problem, then do you have an alternate supplier? So that's risk reduction. And finally, which parts, it says here, which parts should have their ordering levers changed of sales order book scenarios. What this is really saying is, what happens if you forecast that China's going to buy 1 million cars, and then it turns out that actually the United States buys those 1 million cars instead? Those are different cars, and the forecasts are years ahead. How do you actually manage that situation? And what you need to be able to do is to very quickly look at the order book, change the order book, and then see what that means upstream. So you've got a dependency analysis, and that can be really, really expensive. So therefore, there's an awful lot of cost associated with that. So any agility that you can add into that is can save an enormous amount of time and an enormous amount of money. What does it look like? And this is probably the most technical slide I'm going to show today, just to give you an idea of where TIgerGraph fits in. The reason we can go quickly is because we just add on the side of their existing systems. So this, we augment their existing processing. They already use GCP. You can see they use a lot of the Google Cloud infrastructure, particularly BigQuery is their data lake. They use a lot of PubSub for real time. So it's a relatively modern architecture that they've got. And what TIgerGraph does is it pulls all of the information from their raw logs. So that's where we get the data from what's called a raw log storage. It's actually an export of files from their systems, very simple CSV files for those who like that sort of thing. And we load that very quickly. We can load it at well over 1 million rows per second, so we can load enormous amounts of data extremely rapidly. That is loaded into our structure, and then the queries were written as part of the 3-week process. And in the analytic engine, what it does is it calls those queries just like you call any other service, data service, and that data is then incorporated into the data lake when then they're reporting on it directly with Looker and Tableau as it happens is there. But also The other side, which draws from that, is their data science teams and their AI ML teams. They also draw from these. They see what we produce as extra features. Features is everything for machine learning. And so we provide extra scoring features that they can use so that they can look at their modeling and machine learning approaches to future-looking situations, and also for identification of problems when they occur. This is a picture of our next generation toolkit-based approach. So whereas before we were really buried in the infrastructure as a data engine, the idea here is that we were, as I said at the beginning of this, that we want to bring it into the operational space. Rather than those tools just being there for data scientists and maybe a few executive reports, where even though you can get your data in minutes, you're still spending those 25, 30 minutes composing reports or building Tableau dashboards. We really want to bring it to the desk of the people who care about this stuff. So this are the people who manage the supply chain, people who deal in recruitment, people who are in a position to understand their forecast flows and strategies, and therefore be able to actually make decisions on the basis of that. And with that little introduction, what I'll do is I'll flip to the other screen. So this is where we have to cross our fingers, since this is a semi-live demo, and we all know how that goes. So let me just stop sharing a second, and then I will reshare the demo window. Forgive me if it looks like I'm looking above you. It's just that I'm working with two screens, one above the other. Okay, so what you're seeing in front of you here is our next generation interface, is the one that we're composing. This is a prototype. But it is a prototype that is based on applications we have absolutely built. We build these with our partners, or indeed with the customers. If you have that sort of capacity and you're interested in that, then we can provide toolkit components, like graphical components, and we can provide drivers and all the things you need to be able to do this. So this is in addition to the standard web services. You might have your own capabilities here. You might want to integrate with existing tools. We're totally fine with that, but obviously we had to build our own in order to demonstrate it. So this is just a quick idea. So the story around this is that we are getting an overview of operations versus suppliers to try and work out what is going on. This happens to be a electronics component factory. It's relatively simple, but hopefully it will be illustrative. And the first thing we need to worry about is if you're on the production floor day in, day out, you worry about the stuff that's coming through the door that day. And that's exactly what this, on the bottom left, you can see there's a number 2 products with wrist flags. Oh, you can see my pointer acting. So that's the point where we're going to enter here. We have 2 finished goods with compliance flags. We don't know what that means yet, but we know, so we want to have a look at it and understand why there is an issue. So I'd point out that screen, that initial screen, all of those are real-time updated analytics. So as messages come in, then they are reflected in the screens above there. Not only that, and this is probably the most important point, not only are you getting a real-time view, the person who's looking at it, you'll notice at the bottom, there is, in fact, I'll go back. There is this slider here. The idea is that different people will care about different time horizons. Somebody might have a 3-month viewpoint. They're worried about 3 months. They might even be looking into the future. There's no reason this time horizon can't go into the future. But equally, the guy on the floor might only be interested in what's happening that day or that week, in which case they can move this slider and immediately they will see all of these things, because we will recalculate all of this from the source and real time. This is not a cached, effectively just a display on a cached report. This is real data. So moving on, we've got a problem with the product. It's the GPS product. So the first thing the guy wants to see is, okay, so why have I got a problem with this product? This is a finished product that we've got a problem with, that we can see there's an issue on. So immediately they're coming in from the point of not of individual parts, but something that they care about, which in this case is the GPS unit. And what we can see that breaks down via this simple bill of materials is in fact to the Wi-Fi unit. A graph database, and I haven't talked a lot about this, but a graph database effectively is like a relational database, but where linkage between your items is what we call a first-class citizen. The linkage has its own importance. In a relational database, that's not true. In a relational database, you can link, you do link, and you join, but those links are they're static, they're kept in your schema. For us, we can actually create the links after the fact. So for us, the objects here are the Wi-Fi, the individual elements within the GPS unit, and then we add these links later, which allows us to create these very extended linkages, these networks of data. We talk a lot about graph-shaped problems, which are really networks of data. And the idea is that you can do things like this, where given a GPS unit, show me all the parts that matter. And within those parts, show me all the parts with a problem. And that's exactly what this is seeing. We know the GPS unit, we've got an issue here. Maybe we want to fit this to a car or what. And as a result, we need to look at the Wi-Fi unit that's causing us the problem. Immediately clicking on this, you can start drawing all of the related information. So this is coming from different systems at different times. But here we can see a really quite rich piece of information. You've got a picture of the item, because if you're on the floor, that actually might be relevant. You might want to see what it is that you're actually looking for, get a feel for exactly what you're looking at. You've got some overview ordering information in terms of the supplier, what's their capability, and indeed what they're contracted to do. And we can see that projected inventory to get a sense of whether have a loss of inventory is actually going to be a big deal here, not only now, but potentially in the future. So you've got a sense of timescale. When is this going to hurt me? You can also do pretty traditional analytic things, which is to look at what is the explanation of the risk score? We talk about explainability a lot. The idea here is that this is just a click away. You can see the explanation of why the risk score is high here, and indeed the dimensions here on the spider chart. And that's useful because it may be that some of those risks are not things that matter. If you're on the floor and you need parts to build a car, then things like whether there is a regulatory concern around that part may not bother you so much. You may be more bothered about the fact of whether it works. Equally, other people obviously have a tremendous interest in the regulatory aspects. Recently, we've been asked a lot about ESG, which is sustainability, traceability. Can we show that the parts or the elements that you're dealing with are actually fully approved in a regulatory sense? So moving on, we can see there is an issue here. We can see there is a concern. Then immediately the next thing that they're likely to do is say, well, what's my alternatives here? So, what's the context around this? And what we can see is that we do have some alternatives. We have some alternatives associated with an alternative Wi-Fi unit, and we can see them in order of the scoring as far as whether they are good alternatives or not, which is quite important. So since we've got alternatives, then we have the possibility of a what-if scenario. So let's bring that in. And here we are immediately moving into a much more forward-looking, what can I do about this? And this comes back to the point that your tools need to help your operators to actually answer the next question, to do their jobs in their context of their jobs. In this particular case, what happens if we just take that out? What's the impact of not using that component? And I can click forwards and backwards on here, and you can see that some things that were green, lots more things turn red. So just taking this thing out is actually quite an expensive thing to do. We do definitely need to do something about it. We can take an alternative view on this, which is how does this affect the flows of material? If you have a logistic chain and you need to know which logistic flows are actually impacted by a particular chain, then something like a Sankey diagram, which is showing here, actually becomes extremely relevant. So what do we want to do? We want to see if we can replace it with our other Wi-Fi unit. If we replace it, then at that point we can see things look much better. So, and if I can flip back, you can see here it was all red when we took the unit out. But this time when we put it in, then fundamentally we've effectively fixed the situation. At that point, he's got the reason, he can give a recommendation, and that allows them to actually move on into the future. And that, my friends, is the demonstration of what we're doing for JLR. I'm just seeing if there's any questions I can hit here. I've been given the 2-minute warning, which is great. It's probably a 1-minute warning now. But so hopefully I can wrap it up. If this is the kind of thing that you think would interest you, this idea of making your analytics operational, or indeed you just want to see all of your information in one place, linked like this, so you can run analytics against this, please get in touch. Our booth is here, TIgerGraph. I'll be around to answer questions, of course, and hopefully, I don't know, I'm looking forward to speaking to some of you soon. Thank you very much. Oh, Sonia's come up with a question, so until she cuts me off, this example applies to supply chain. Are there other parts of the business that your solution has a big impact? Yes, absolutely. As I said at the beginning, we're used in, because we've effectively created a model, and we're talking, one of the things we're talking to JLR about is actually digital twins. Because this model is so applicable, we can do this everywhere. Anyway, I'd love to answer questions around this. I think I've run out of time.